A mosaic puzzle is sort of like Minesweeper. There's a collection of cells and certain numbers appearing in some of the cells. But instead of the numbers telling you how many bombs are around it, they tell you how many squares around it have to be colored black. So for example, this 0 here tells you that 0 of the squares that I've lit up in red here are black. Now a square can only be black or white, which means these would have to all be white. These corner ones have a slightly smaller neighborhood, so there's only 6 cells in the neighborhood, so you would know immediately that these must all be black because there are 6 blacks around them. Or in the corner, you would know that if there's a 4 in the corner, these would necessarily be black. And typically you sort of proceed from the easier clues to the hard ones. So for example here, this 0 is easy to solve because it just tells you that there are no blacks around it. And then only because you've solved these 2 whites is it easy to solve this 7. Since there are 7 blacks around this, and the only unassigned cells here are these ones, and there are 7 of them, it means that these must be black. This would then be solved because it already has 3 blacks. This would be solved, it has 2 blacks already. This only has 1 left, so that would get you to 5. This is at 5, this is at 6. So you would sort of solve in that fashion. So yeah, the easiest patterns, of course, are the 0, where you can immediately see that there are no blacks, and the 9, or as we saw before, the 4 in the corner, or the 6 on the edge. Then there are slightly more complicated patterns, such as this one. In the red neighborhood of this, there are 3 blacks, and in this blue neighborhood, there must be 6 blacks. So anytime you're seeing this pattern, you know that this purple region is a neighborhood of both the 3 and the 6. Since the purple can only have 3 blacks, and the purple and the blue together must have at least 6, it follows that these must be black, and the other remaining 3 blacks have to be in here. So anytime you see that pattern, you can immediately deduce that you have 3 blacks and the 3 whites. And you can actually do the same logic anytime it's +3, like this. So if this is +3, you would immediately be able to deduce these +3. This one's obvious for a different reason, but it's the same logic. Then there are more complicated patterns, such as this. If you had a 1 and 7 at distance 2, you know that there's only 1 black in this red neighborhood, but you know the blue and the purple, so this blue neighborhood shares with the red neighborhood these 3. You know that it can only have 1 in the purple, but it needs to get to 7, which means you would immediately know that these must be all black. And there's 1 black somewhere here, which would satisfy this 1 then. So this is a more complicated pattern. And more or less you're going to just utilize those sorts of patterns and propagate them through the entire grid. So you know, this is 0 here, there's a 1 somewhere here, which means these must be white because the black is somewhere here. And in an actual grid you would be able to solve absolutely everything. In this case you can solve this, but you would have numbers in every position to be able to solve them all. Okay, so let's solve one of these grids together. Here's a 10 by 10. So with these, typically you'll look for starting locations like a 4 on the corner, a 0 on the edge, 0 on the edge, well 0 really anywhere. And then you'll just start with one of the places. So this 5, based on the fact that there are already 4 whites, and that means 9 minus 4 is 5, the last 5 cells must be black. Then this 2 is solved. You can't necessarily proceed through the entire puzzle from one starting location, so there's nothing you can really do with any of the hints that are bordering the solved squares, so you would then move somewhere else. So 9 minus the 2 white is 7, so you know that remaining 7 cells must be black. This 1's already solved, this 7's then solved, the 4's solved, 7's solved, and so on. So you're sort of always just using the fact that some of the cells are deduced, so of the 6 neighbors of this one, you already knew that 2 of them were white, which means the last 4 would have to be black. So you're always propagating the knowledge that you've gained from solving some of the grid cells. So for example, this 3 is solved, which allows you to solve this 5. This 5's now solved. The 6 only has 6 cells around it that can be black, so that's solved. This has got the 3 white, so the other 6 have to be black. And you just propagate through. 4's solved. 7's now solved. The 5's already got them. 7 has 2 white. This has already got the 4 white. Solved, solved, and so on. So you can get the hang of the main patterns. Like so. And then that's solved.